So this is model evaluation here. So in this fifth lecture, we cover the model evaluation. First, what is model evaluation? Model evaluation means checking how well our machine learning model is working. Suppose we have to created a machine learning model to predict which customer might be interested in our product or offer. Model evaluation helps us check how accurately the model makes those prediction. So model evaluation, we covered two things: how to perform model evaluation using Python, and next is accounting for unequal errors using Python. So first, we understand with an example. We have an example. We have two data sets: clothing data driven training and clothing data driven test data set. And our task is to predict whether or not customer will respond to a phone mail marketing campaign based on three common predictors. So here our three common predictors is days since purchase, of purchasing widgets, and sales per widget. So the target variable is a flag response coded 1 for positive response and 0 for negative response. This is the scenario that when we call a person is interested or not. So based on this, we target flag, we make our target flag is 1 and 0. So model 1, first of all we create a model C5.0 model for classifying response using the clothing data driven training data sets. So we train our model with using clothing data driven test dataset, training dataset using. Create a model 1, and when after the creating of model 1, we compare our predicted response values from model 1 and actual response value from the clothing data driven test. Here what actually I actually do that we compare between our actual data that is used for testing the data set, testing our model, and you with predicted response values from model 1. So after the comparison between these two things, be given that here the question given that total actual positive 1940, actual negative, and grand total. Now after 8 measures, we create a 8 C5.0 tree, and after this we create a contingency table for evaluating the model. So this is the actual contingency table here. Total negative 9173, total false negative, true negative, false negative. So this is the contingency table here. After this we accurate for all negative. So for all negative we see here total actual negative is 9610. So 9610 upon total number of predictions here 11554. So this is 0.8321 for model 1 all. This is the accuracy of total actual negative, and for model 1 for all negative that gives by model 1. So this is a model 1 accuracy 00, total negative 9173. So this is our total negative 9173, and total examples that I give in the in our model, in our train for using the training of our model. So this is 9614. So the accuracy of all negative of model 1 is 9541. After the evaluation, we see here actual negative records as negative. That is, the model is doing great as correctly identifying customers who would not respond to the marketing campaign. However, the model sensitivity is 0.2804 is rather poor, meaning the total positive, for total positive 28.04% accurate our model predict, and for total negative our model is 95% gives accurate answers. So for here is an error because our negative, for our negative data our model is perfectly work, but our positive data is not perfectly work. So we need here of the actual positive records were classified as positive by the model. So here we need 55.23%. So I will explain using code here. Import pandas at pd sample. First of all, we connect our Google Drive here. Files not. Yes, I connect with Google Drive. So we understand. First of all, training data is data since purchase, number of purchasing visits, sales per visit, and response. Sample data for clothing data driven test, base since purchase, number of purchases visit, sales per visit, and response. Create data frame. First, we create data frames for all the clothing data driven training. .csv clothing data driven test for test.csv. So here, load the data, read.csv here, trend.csv here. Step 3, trend the model, clothing training, and clothing trend.response. Xtrend is our features and bytrend is our predictor. Create and fit the model. Model decision tree classifier. We create a decision tree here. Model.fit xtrend bytrend. Make predictions here. And after this, at last we create a configuration matrix for total. So this is our output. I run in front of you again. No, it is not connect Google Drive, so I connect with this Google Drive using connection. Yes, it is run. So this is our output. Sample.csv5 created successfully. Distance purchase, number of purchases bids, training data columns, testing data columns, and this is the actual of predicted 0, predicted 1, and total. So this is our output of model evaluation. Next is accounting for unequal error cost using Python. Accounting of for unequal error means here a problem occur that shopkeeper trying to decide call which person some people want to buy and some are don't buy to want to buy our product. So people want to buy our responder false negative and other are non-responder false positive. So if we contact non-responder, this is our waste of time, and now our model cannot able to calculate right cost. So our aim is to correct machine learning model. So let's consider an example to clarify this problem and our goal here. So false positive, these are the non-responder. If we contact these people, then we waste our $10. And false negative, there are responder. If we don't contact them, the we waste our $40 because they purchase something and we gain profit here. So our model consider this error as an equal error in both cases, $10 and $10. This is our aim actually. Our aim is actually we want to evaluate, we want to set actual cost of our equal error. So this is our equal error cost is $10 and $10. In this case, we want to same here. But our model cannot understand this difference. So our goal is to calculate the unequal error. This is the unequal error here because sometimes it takes $40 and sometimes it takes $10. So we prepare cost matrix to solve this problem. It is a matrix that explains the cost difference of model of false positive and false negative. So predicted category is 0, 1, actual category is 0, 1. Total cost and total false positive. So we create this. After this, we can evaluate our unequal error here. So this is a code I explain with using executing the code here. So this is the execution of our code. So this is the code of our calculating unequal error. Load the tries data sets here, load.iris and iris.data, iris.target here. Split the data into training and testing data here. So we can split the data into training and testing data set here. Create and fit the decision tree model here. So decision tree classifier, we can create a decision tree and we can fit the model using xtrain and bytrain. Make prediction for the test set, model.predict xtext, and we can create a confusion matrix here. So here we create a confusion matrix x by test and by prediction here. Classification report, class report here. Figure size 86 plt dot figure. So this is our classification report. This is our classification report and this is our classification and confusion matrix here. This is our output here. So this is the end of this lecture. And now our next topic is, I will explain our next topic in this series. Our next topic here, NAP based classification. So next topic I will cover NAP based classification.